Now we're going to work through decomposition reactions. There are a lot of different types of decomposition reactions. We're not going to work through all of them, but we are going to work through the main ones. The first one we're going to work through is binary. You're going to know it's binary because it only has two elements. Each element is recognized because it is a capital letter. So here we have H2O. That is going to break up into hydrogen and oxygen. Now, remember that hydrogen and oxygen are a part of the Gen family, which we said cannot be alone, so it has to have a subscript of 2. These are diatomic molecules, so we have to write H2 and O2. When we write the completed reaction, you have H2O yields H2 plus O2, and now we need to balance. 2 H's, 2 H's, 1 O, 2 O's. So we have to double the water. By doubling the water, we double the amount of hydrogen, so we have to double the amount of hydrogen in the products. That gives us a balanced reaction. Calcium carbonate. Calcium is a metal. Carbonate is a polyatomic ion that you're going to find on your polyatomic ion chart in your reference tables. Oops, I circled carbonate. So we have a metal and a carbonate. A metallic carbonate, here let's color code these so we keep them straight. A metallic carbonate is going to decompose into a metal oxide and carbon dioxide. The metal that we're dealing with is Ca, so we're going to make a metal oxide by saying it's going to form an ionic bond with oxygen because it's a metal and a nonmetal, and then we're just going to add CO2. When we crisscross these charges, the charges cancel out. So when we rewrite the complete formula, we write CaCO3 plus CaO plus CO2. Let's make sure it's balanced. 1 Ca, 1 Ca, 1 C, 1 C, 3 oxygen, 1, 2, 3 oxygen. So this equation is balanced. Next problem, calcium. We have a metal. The second part of this is in parentheses, so it's pretty easy to identify that it is polyatomic ion because inside those parentheses, it's 2 capital letters. That polyatomic ion is hydroxide. So here we have a metal hydroxide. Metallic hydroxides break apart into a metal oxide and water. So the metal we have is calcium. It's going to be a metal oxide, so we're going to bond it to water in an ionic bond. And then we're going to add water. When we crisscross the charges, we know that they cancel out. So you have CaOH2 gives us CaO plus H2O. Now let's make sure it's balanced. 1 calcium, 1 calcium, 2 oxygen, 2 oxygen, 2 hydrogen, 2 hydrogen. So that's balanced. Okay. Example number 4. Potassium. Potassium is going to be a metal. ClO3 is a polyatomic ion because it has more than one capital letter. Don't ever mistake that Cl, that L for an I. It's a Cl and it's chlorate. So we have a metallic chlorate. That gives us a metal chloride, and oxygen. The metal is still calcium. So we're going to have potassium bond with, oops, excuse me. The, the metal is not still calcium. The metal is potassium. And it's going to bond with chlorine. And then we're going to have the metal chloride and the oxygen. So the final equation is going to be KClO3 plus the metal chloride plus oxygen. That should be an arrow. Now, let's see if it's balanced. We have one potassium, one chlorine, three oxygen, and two oxygen. The only way to make 3 and 2 equal to each other is to get them both equal to 6. So what we're going to do is we're going to double the calcium chlorate, and then we're going to triple the oxygen molecule. Remember, it is O2 because it's a diatomic molecule. Once we've doubled the calcium chlorate, or potassium chlorate, I keep saying calcium. Once we double the potassium chlorate, then we have to double the potassium chloride on the other side. That makes that equation balanced. Now, the last one, H2CO3. Anytime you see a molecule with H, you're going to think that it's an acid. Then it's also a carbonate because it's got the oxygen. It's not a metallic hydrogen carbon, so it has to be an oxyacid. Don't let oxyacid intimidate you. It just means that it is an acid, so it starts with an H, and it has oxygen in it. This is an acid because it starts with an H, and it has oxygen in it. This is going to decompose into a nonmetal oxide and water. This is all information that you have in your reference tables that you'll be able to use as you do your assignments. So this, the trick that I have for decomposing acids or oxyacids is to simply subtract the water from the acid. So it has H2 minus H2, they cancel out. So in the nonmetallic oxide, we know that there's not going to be any hydrogen. There's no carbon in H2O, so carbon's going to stick around. O3 minus one oxygen is O2. So that means that our nonmetal oxide is CO2 and then plus water. The final equation would be H2CO3 yields CO2 plus H2O. Let's make sure it's balanced. Two hydrogen, one carbon, three oxygen, three oxygen. That's balanced.